Welcome to another Autodesk Inventor tutorial. Today we will be looking at constraints. There are 12 different constraints in total, and let's start and get through them. Okay, the first constraint I'm going to talk about is the coincident constraint. And what this basically allows you to do is have two lines touch, which can be very useful if you want to make sure things are touching and it's not abundantly clear, or if you think they're touching and you're having a problem with it extruding that shape properly, go back and make sure that it's actually touching by using a coincident constraint. So if you see here, Inventor will kind of lock on right there, and it's automatically creating a coincident constraint if I were to start a line off of the circle. But if I create this other end of the line not touching the circle and I want it to touch the circle, would go up here and click the coincident constraint, and then I would choose the endpoint of the line, and then I would choose the edge of the circle, and then click OK. And you can see that brought the line up, and where this yellow dot is, that means it's on that circle. It's a coincident constraint is made. And I can also do the same thing with the center of the circle and the bottom of this little triangle here. I can bring that, put that in the center, and so now that is centered on the circle. Now this could also be useful if, say, you are wanting to make a cutout from this circle that's kind of a rounded shape or some other crazy shape, and in order to get it to be perfectly aligned, you're just going to mirror it so it's symmetric on that circle. And so I'm going to create a couple lines here. This one is just for construction, so that's not actual physical part of the line. And then I'm going to mirror this curve across this construction line to come back up over here on this side, on the right side of the circle. So I'm going to mirror this really quickly, select that, and then select the mirror line, and click apply. And you can see, yeah, these two lines right here, and it looks like they're touching. But if you notice, there's no yellow dot on the end of this line. And if I were to go ahead and try to extrude this, it's not going to actually work. See, it'll only let me select the entire circle, and I can't select just that part of it, just this little shape right here. So, in order to do that, I'll go back and edit the sketch, and if I click on the coincident constraint, and click on the edge of this curved line, and then click on the circle, now that coincidence is made, and now those two lines are actually touching and are one piece. So I can go ahead and extrude this, and you can see it now. It lets me select each part of it individually. So I can select the outside, or I can select this little wedge here. So if you're trying to do something like that and you're having a problem with it not extruding properly, make sure the coincident constraints are there, double check it, and hopefully that would solve the problem. So I'll go ahead and delete that. And now we're going to go look at the collinear constraint. And what this basically does is make sure that two lines are on the same line. If they're like two separate unattached lines, to make sure that they are on like the same basic line. So if I were to create like a sawtooth shape, sort of like this, and bring this one down here, just make that shape whatever. Okay, and you can see if I want this line and this line to be matched up, they're obviously not. And I can try dragging it up, but that's I can dimension everything and make it work that way, or I can just click the collinear constraint, hit one, and then hit the second one, and you can see they brought it down to each other. And it kind of averages out the two of them. Inventor will sort of choose how it thinks you want it to be. Sometimes it works out, sometimes it doesn't. So if it doesn't work out how you want it to be, just go ahead and go through all the dimensioning, and then you can make it properly how you want it to be. So that's basically collinear constraints in a nutshell. They're pretty simple, but pretty useful. So the next constraint is going to be the concentric constraint. And the obvious use case for this is two circles. Just like this, you can put them anywhere you want. And if you want these circles to go around each other perfectly, so that essentially means that their center points will be right on top of each other at the exact same location. You can use the concentric constraint with that, and then it'll put the two together just like that. You basically hit the concentric constraint, select one circle, and then select the second circle, and it will put them together pretty simply. And then say if this was going to be a pipe, you can go ahead and extrude that, and there you go. Pretty simple. Another use for the concentric constraint is having a rounded edge on a rectangle. I'm going to go ahead and dimension this real quick, make that 8. And I'm going to fillet these two corners to basically make it a round edge, a circle, a semicircle. So because I know this is 8, I'm going to make this 4, the size of the fillet 4 to be half of 8. Click on one side, then click on the second, and then click on the other edge, and now you can see there's this basic circle here. And if I want to put a hole like right at the center of here, and I kind of missed the little green dot there where it snaps into the center of it, say I click over here, I can go ahead and hit the concentric constraint, and basically I can click on one of these edges right here, and it'll bring it to that. Now if the fillet was smaller, say 1 millimeter, like over here, well, it's not going to work quite the same, because if I were to make a circle here and hit the concentric constraint, it's going to want to choose one of these center points. So you can either do one size or the other, and you can see that sort of brought it down to that one. And so that's why if you want to do something like this over here on the right side, you have to make sure that the fillet is half of the height or width of the rectangle to work properly. Okay, so that is concentric constraints. The next one will be the fixed constraint, and that's basically have a shape or object or whatever, and if you want it, say right here, and you can go ahead and dimension it how you want it to be. It doesn't really matter right now. And you can go ahead and go through that, but if you just are sort of eyeballing it and you don't really care too much where it is in terms of from the origin, you can go ahead and click the fix constraint and select each line, and that will basically lock it in place. So now, as you can see, I can edit this rectangle. I can move it around if I want to. I can do a whole lot of things with it. But this one, it's fixed, so I cannot move this unless I were to go ahead and delete the fixed constraints, which is what this lock icon is. If I were to delete that, and I probably have to go ahead and delete a couple other of the lock constraints or fixed constraints before I can really start futzing with it. See, so if this one side is fixed, that basically means I can't move this side to side, but I can still stretch it out by extending these two edges right here. So that is basically the fixed constraint in a nutshell. The next constraint I'm going to go over is the parallel lines constraint. And what this does is make two lines parallel. It's pretty clear what it does, but just to talk about it, I'm going to make this shape. No two sides are parallel, but if I want them to be, I can easily do that by clicking on one. After I click on the parallel constraint icon, I can click on one line, and then I can click on the second line, and then it brings them to be parallel. It's pretty simple. It does just what you think it would do. The next line, or the next constraint I'm going to go over is the perpendicular line, or sorry, perpendicular constraint. And that does what you would also think it would do, is basically make two lines perpendicular to each other. So if I were to make a crazy shape like this and I want to make a square or a rectangle, I can do that by clicking on the perpendicular constraint and then clicking on two lines. And of course that will make these perpendicular, which means 90 degrees angle between the 2 points. And if I were to go ahead and select at least 3 of them, if I were to try the 4th, it might be over constrained. Yes, it will be, because 4 corners add up to 360 in an object, and if I have 90 set, this one has to be 90, so it knows it's going to be perpendicular. So if you try and do that last corner, it's going to probably throw this error at you because it already knows it's perpendicular. The next constraint I'm going to go over is the horizontal constraint. And what this does is it takes a line and makes it parallel with the x-axis. This is very important. It's the x-axis. It's not horizontal on your screen. It's parallel with the x-axis. So right now you can see the x-axis is horizontal on the screen. But if I were to rotate this view so that the x-axis is vertical, and I use the horizontal constraint, well, it's still going to want to make a vertical line here because it's parallel with the x-axis, which is also vertical. And you can see that's what the yellow dotted line means, is that's the line it's going to be parallel with. It may not be exactly at this point. As you can see, it wasn't. But if I were to undo that and do this again, it's going to be parallel with the x-axis. And similarly, if I were to undo that, if I were to make the vertical axis, vertical constraint, this works in the same way as the horizontal, except for instead of using the x-axis, it uses the y-axis. So right now it wants to be it's going to want to be parallel with the y-axis, which right now is horizontal, and that's why you can see the yellow dotted line is horizontal instead of being vertical. It's just follow the x and y axis, and if you're far away from the origin, you can always look in the lower left corner and you can see basically what angle you are at in 3D space with the x, y, and z. So now the y-axis is back to being top and bottom. So if I were, or vertical, if I were to click on it now, it would make that a vertical constraint. And if I wanted to be extra thorough and make this the top line horizontal, well, it's probably going to give me an error because it's already over constrained, because the corners are perpendicular and this is vertical. So if this is vertical and it's perpendicular with this has to be horizontal. So it's already constrained like that. Inventor will actually be fairly smart with things like that. The next one that I'm going to go over, I'm going to rotate this again, is the tangent constraint. And what tangent means is basically the line will only intersect at one point, say through a circle. So this line is not tangent and that line is not tangent because it intersects the circle at 2 points, right here, and then for this one, right here and right here. And so if I were to use the tangent constraint, what it would do is bring this line down here and then this line up here, right on the edge of the circle, and it'll basically allow you to create a perfectly smooth transition going from the rounded edge to this line, to a straight line. So I'll go ahead and click on the line and then click on the circle, and the order of operations for this doesn't matter. You can click on the circle and then click on the line, and you can see how that worked. Now if I were to want to say trim this and say make a circular end to this shape, I can go ahead and trim that, trim off this excess side on the left, which I do not want, and then trim out the inside part of the circle, and now I have a nice rounded edge like this, sort of similar to how we made the rounded rectangle with the 2 fillets. This is probably a better way to do that. So if I were to want to make a circle concentric with this, I could do that and then make a click on the edge, I can make a hole if I were to extrude this all in one go. So you can see, how that shape works. Okay, so the next constraint I'm going to go over is the smooth constraint. This, in all honesty, can probably be the most finicky constraint that there is, and I will show you why. But the idea behind it is to smooth out two lines so that they come out, like say you have a spline between two lines and you want it to be a nice smooth transition. That's what you would use this for. Unfortunately, like I said, it can be pretty finicky. So if I were to say, as an example, create a line there and then a vertical line, say over here, and I wanted to make a nice smooth transition between them, well, the next thing I have to do is make a spline. But that connects the two of them, and say, just for exercise purposes, I'm going to purposely make it not a smooth line coming out of there, and I'm going to use the smooth tool. And that worked out pretty well. This worked out pretty well. So now you have a nice smooth edge. However, this can get very, very finicky. So if I were to, make a line here and then make another line over here, and say I want a spline, like a nice sort of rounded shape that goes between the two lines, just like that. Okay, so you would think if I were to use the smooth tool with this line and then this with the spline, this would just continue straight and smooth. Well, it changes a lot. If I were to do this one, that changed it a lot. So this obviously is nowhere near the shape I wanted. I wanted those two lines to have that angle coming out. So you have to be very careful with that. And so even if I were to fix these two lines in space, it still isn't going to be perfect. You can see it changed those two lines, and then if I were to do this again, well, that'll over constrain it for some reason. So it can be a little crazy. So I'm going to go ahead and fix this, and then I'm going to also dimension this to keep the line the same, the length that it is. And then I'm going to go ahead and do the smooth transition. See this? Okay, so this is another thing. You can see all these little dotted guidelines for the spline. This one is blue. This is why it was giving me that over constrain, because when I drew this, Inventor automatically constrained this part of the spline to be horizontal. I don't want that. I'm going to delete that constraint. So now it's back to a yellow line. So be careful for things like that. Now if I were to use the smooth constraint on that, I can do that. And obviously it changed the shape a lot even still, so what you might have to do is go ahead and reposition some of these control lines. You can see these are now blue dotted lines, and that is because I think that is how the smooth constraint works, is it makes this line, this guideline, the same along, basically collinear with this line right here. So if I were just to try something, I'm going to say delete that tangency, or that smooth constraint, delete that one. I'm going to try making, okay, first of all, I'm going to bring these so they're not collinear, and I am going to make this line collinear with that one, and it sort of does the same thing, but obviously not quite the same over here. So, be careful with this. As I say, it can be finicky. If I were to say make a couple splines that I want to attach, even if they're not connected, you can do that with splines, but you can't do it with lines, where you can take this one and connect it with this one, and it'll sort of make that shape. Sometimes that comes out pretty well, like that one did, and then sometimes, depending on how your shape is, if I were to have, say, something crazy over here, and I wanted to join the two, well, that wasn't really what I was thinking. I was sort of more hoping for a smooth line going along there. So be careful with how the lines are going from each other. So if I were to, maybe if I could, actually, let's try this. So attach this one to this one, and then maybe attach this one to this one, if it would let me. That's a little bit better, but still it's kind of crazy, so be careful with this. It's finicky, to say the best, or say the least. Now the next constraint is the symmetry constraint, and this can be pretty useful for a couple things. One is, say if I want to make an angle that is equal on each side. I'm just going to exaggerate that so it's not. I can go ahead and click the symmetric constraint, and you choose the two lines that you want to change or want to make symmetric, and then you choose the middle line, the center line, after that. So it's 3 clicks. It's 1, 2, and then 3. And now, just to show that these are the same angle, that's 59.2 right now. If I were to change this to say 20, the right line will change as well. So you can see how that got even closer to each other. And I'm just going to give this one a vertical constraint so it's a little bit easier to see. Change that again, it's 50 degrees. And just to measure this, it's also 50 degrees. So that's one use case scenario for this. Another one would be what I'll show you right now. So I'm going to go ahead and create a center line. I'm going to make this for construction. And I'm going to create a rectangle that is not centered. And I'm going to create a couple circles as well. So this works with a few different things. I can make the circles symmetric across this line by clicking one circle and then clicking on the next circle, and then now choosing the center line. You can see that'll also make them the same size circle, because it's symmetric, it has to be the same size. And then I can also position one and adjust the other one as well. So you can see how that works. I can also do the same thing with the two lines of this rectangle to make it centered across this axis by clicking on the left one and then clicking on the right one and then clicking on the middle center line, and now you can see that they are symmetric across that center line, and as I adjust one, it adjusts the other relative to this line. I can still make it taller, and one thing I can do is I can put these circles inside of it, and if I wanted to be, symmetric with these circles and make holes, I can do that. I can also, say, create another line for construction and make it symmetric top and bottom with that line. And so now, as I adjust this, it adjusts on, let me get that back into view, it adjusts the top and bottom as well, and based off of the horizontal line, and then obviously these adjust based off the vertical center line. Now I'm going to do the same thing with these circles, 1, 2, and 3, and well, that didn't quite work out how I hoped, because they are symmetric across two lines, and they're basically just, it's basically a circle is just one rounded line, and if it's symmetric across two different lines, it's going to basically create it at that intersection of the two lines. So that's not going to work very well. So that is the symmetry or symmetric constraint in a nutshell. Now the next constraint and the last constraint is the equals constraint, which is pretty much what you would think it would do. It makes two lines equal size to each other, or two circles equal size with each other. So if I were to make this line equal with this one, it's the same length. It's not necessarily parallel or anything like that. I know this symbol kind of looks like the parallel symbol, but remember, equals is two horizontal lines, and parallel is two angled lines. So these are the same length actually right now, and if I were to make this one the same length as this one, you can see how that changed. And just to sort of prove it, if I were to make that line, see how long this is, and just to see how long this one is, that's 100. And that is a driven constraint. That's what those parentheses mean. I have Inventor set up. I went through the options and changed it so that driven constraints are just displayed with parentheses instead of getting a pop-up warning. So that's basically equals constraint for lines, but if I were to do a circle or a couple circles and then do equals with those, well, it's the same basic thing. It makes the two circles equal size with each other. And so that is basically all the constraints that Inventor has. If you wanted to, show the constraints for a line or for a shape, you can do that by selecting on them individually, or you can also, highlight the whole thing. So that's basically that. And then you can adjust constraint settings to say basically how you want it to automatically make constraints while you're drawing the initial sketch, or how they display them, or whatever. You can go through these options on your own. So I hope you learned something. If you did, hit that like button, leave a comment, let me know that you liked this video. If you didn't like it, go ahead and click that unlike button. But if you want to see more of these videos, more of these tutorials as they come out, hit that subscribe button so you'll be the first to know, and you can continue learning how to design things in Inventor. So until next time, thanks for watching.